Hey guys, so today we're going to start with the topic of probability and counting. Some of you may have done a little bit of this last year. So probability deals with the likelihood or chance that an event might occur. For example, if we take the probability that you will get a heads when you flip a coin. So we know that when you flip a coin there's two sides. There's heads or tails. So we know that you have a 50-50 chance of getting heads or tails depending on what side the coin will fall on. And this is what we call a fair coin as well. It's something that's, there's nothing wrong with the coin. It won't land on its edge so that it doesn't fall on heads or tails. Okay, so you might want to pause the video here just to take down the notes, and I'm just going to run through them. These are the key terms to do it, so that would be your heading, key terms to do with probability. And you need to get used to these key terms because we use them quite a bit. So, first of all, a trial is the act of doing an experiment in probability. The rolling of a standard 6-sided die is an example of a trial, or the trial that I just said there about flipping a coin. The set or list of all possible outcomes in a trial is called the sample space. So if we were to look at the sample space of flipping a coin, and let's say we say S is the sample space. So I'm going to use my curly brackets here. So my two outcomes flipping one coin is either heads or tails. If we take the example of rolling a die, well, we know that the sample space, so all the possible outcomes that we could have is 1, 2, 3, 4, 5 or 6. And then on that, an outcome is one of the possible results of a trial. So when rolling a standard 6-sided die, one possible outcome is 4. We can see that we've 6 possible outcomes here. Finally, the event is the occurrence of one or more specific outcomes. So when we refer to events, you will often see this notation P with brackets and tail, and that just means the probability of getting a tail. The event in this case is to get the tail when we flip a coin. So now I want you to attempt this question. 2 coins are flipped. Write out the sample space of this trial. So if you want to pause the video here and attempt this, so you can start with saying S equals and a curly bracket. So you can say HH is one of them, so where you get 2 heads when you flip 2 coins, and write out the whole sample space. Okay, so writing out the sample space then, I can get heads, 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 tails, tails, heads, tails, tails. So we have 4 outcomes. Total is 4 outcomes. And then the question here, what is the probability that we get the same side on both coins? So what I need to do here is I need to get the number of outcomes. You can take this down. This is for probability. The number of outcomes over the total outcomes. So in this case, we can see that we have HH and TT. We only have 2 where we will have the same side. So that's 2. And our total number of outcomes is 4. So that's 0.5 or a half. So here's another question that I want you to try. A fair die is thrown and a coin is flipped. Write out the sample space of this trial. So again, pause the video here and have a go at the first part of this question. And then the second part is, what is the probability that I will get a heads and an even number? Okay, so I've written out this sample space a little differently this time. We're going to do a little bit more of this. These are called two-way tables, and we'll be doing a little bit more later in the chapter. So first of all, to roll a die, 1, 2, 3, 4, 5, 6. These are the outcomes that I'll have. And to toss the coin, we know heads and tails are the only outcomes that we'll have there. So what I got then was H1, so I can get a heads and a 1, heads and 2, heads and 3, heads and 4, heads and 5, and so on. Similarly, I can get tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. And what I can see is there's 12. My total is 12 outcomes. There. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What is the probability that I would get a heads and an even number? So I can see I have an even number here, heads 2, heads 4 is an even number, and heads 6 is an even number. You can write it out the way I did it with the curly brackets as before. I just thought it would be a nice idea to kind of introduce two-way tables to you here, but we'll see more of them later. So then I get my number of outcomes, which we have 3, over my total outcomes, which is 12. And that will give me 1 over 4, or we know that's also written as 0.25. So what we know now is that for equally likely outcomes, probability is equal to the number of outcomes of interest over the total number of outcomes. So here's a question for you, a little bit more complex than what we were looking at. A bag contains 4 white marbles, 6 red marbles, 4 green and 2 blue marbles. A marble is taken from the bag at random. Calculate the probability that this marble will be. So first of all, what I need to do here is I need to figure out how many marbles in total. So I'm told 4 plus 6 gives me 10, plus 4 gives me 14, plus 2 gives me 16. So 16 marbles in total. It'd be a good idea to take down this question as well as another example, similar to what we would normally do in class. So we now have, so the P of E, so let's say the first one here is the P of white, so let's say call it W. And that's going to be, we know that there's 4 white marbles in total, over the total number of marbles is 4 over 16, which gives me 1/4, or also 0.25. Let's have a look at blue. So let's call it the P of B. And the P of a blue marble, so we know we have 2 blue marbles, all over 16. And that's going to give me 1 over 8. Now, I want you to try the not blue. So let's say the P of not B. Have a go at that one for me now, please. So what we can do here is that we can count up all of the other marbles that are not blue. So we 4 plus 6 plus 4 gives me 14 in total. So 14 over 16. And that will give me 7 over 8. Now there's another way of doing it as well. We've already found that the possibility or the probability of a blue marble is 2 over 16. So another thing that I can do here is take 1 minus 2 over 16. And that will give me 14 over 16. We'll talk a little bit more about that later on. Finally, we have D, which is the probability that the marbles can be red or blue. So we're going to try and find the P of R or B. And what we know is red marbles. So we have 6 red marbles plus blue marbles. We have 2. And that's all over 16, and that will give me 8 over 16, which will give me a half, or 0.5. Okay guys, so go ahead and attempt the homework on this. It's question 17 and 18.